A good way of making unsymmetrical ketones is by reacting a nitrile with either a Grignard or an organolithium. The way it works is you have a nitrile and you have a Grignard. The electrons from the carbon-magnesium bond add to the nitrile carbon, and electrons go up onto the nitrogen. Here we have a case of a negative nitrogen being formed. The reason why we can form a negative nitrogen in this mechanism is a Grignard reagent or an organolithium reagent. Well, that's essentially a negative carbon. Negative carbons are much more basic than negative nitrogens are, so you can use them to form negative nitrogens. However, you have a new carbon-nitrogen pi bond. Your Grignard cannot attack this because then you would end up with a nitrogen with two negative charges on it, and that is way too unstable to form. And so this waits around for you to add the acid-water workup step, in which case that is protonated to form the imine, or you could use H3O plus here. And imines, in the presence of acid and water, well, they go right to ketones. The mechanism of this is you protonate the nitrogen of the imine, and you can use your acid source like ammonium chloride. And then water can then attack the imine carbon. A quick proton transfer to solvent. Followed by taking that proton from the protonated solvent and protonating the nitrogen to form a better leaving group. And then the electrons from the oxygen can come down and kick that nitrogen off. And water can come again and take that proton to give the final product. And this reaction essentially takes a nitrile and it works with either a Grignard reaction or an organolithium to give you a non-symmetrical ketone where one of the carbon groups comes from originally from the nitrile. The carbonyl carbon is the nitrile carbon, and then your other group comes from your Grignard or your organolithium.